All right, we are on 3.4 part A and part B. So part A, we're going to first analyze the sine as a function. So sine theta or sine x as a function. Okay, with a function, there are multiple representations of it, correct? We have tables, we have graph, we have word problems, we have our equations and all those things, right? Our multiple representations of functions. So we're going to talk about how to identify that. Well, let's think about it. On your unit circle, are you not given x's and y's? And x's and y's can make a what? A table, and a table can make a graph. Okay. Okay. So it's a type of graph, and it's already kind of graph for you. But we're going to analyze each one on its own. So you're analyzing the sine at this point, the cosine at this point, the tangent at this point, and we're going to be introduced to their reciprocals today. And go from there. All right. So sine function, we're going to fill in our sine values only on our table. So using your brain and or your unit circle, you're going to fill in only the sine values for our values on our unit circle. Okay. So like the sine of 0 is what? Sine of 0? 0. Sine of 0 is 0. Uh-oh. So sine of 0 is? I wrote a 0, I promise. I don't know why it's not registering as a 0 being written. There we go. Sine of pi over 6 is 1/2. Sine of pi over 3. Square root of 3 over 2. Sine of pi over 2. It's 1. If I hear 1, yeah. Sine of 2 pi over 3. Sine of 5 pi over 6. Sine of pi. Sine of 7 pi over 6. Sine of 4 pi over 3. Sine of 3 pi over 2. Sine of 5 pi over 3. Sine of 11 pi over 6. And sine of 2 pi, 0. Okay, so we pulled all of our sine values. Now we're going to look at this on a graph. So we're going to go to our handy dandy graph calculator. All right, here's Sylvie. I'm going to go ahead and put in my sine function. My sine parent function is y equals sine x. We're going to put in y equals sine x. Oh, you're so funny. All right, so when I hit graph, look at it. Our periods and our amplitude and all of these things. It did. No. All right, we're going to adjust our window. We're going to adjust our window to fit the values of our table, okay? So looking at our x values are counting by 6s. Do we see that? Yeah. Pi over 6, pi over 3. Huh? Did you put an x? Go to y equals. And you type sine x? You sure? I don't know what you did. Just tell me to come talk to you. All right, so what was that? All right, so we're gonna change our window. So to change the window, there's a couple of things you can do to begin with. If you go to Zoom, there is a trig option. So if you go to Zoom, you see where it says trig, it will adjust your window. So we went to Zoom and you'll see 7 where it says Zoom trig, and it'll adjust your window. So you can kind of see values. So there's that. But we're also going to just adjust it manually. When you're putting it in calculators for our table or our values, our x min, what is our smallest x value we have? Our smallest x value is 0. Our max x value is on our table that's in front of you. Our smallest is on our table. We're changing our graph to match our table. 0 to 2 pi. Agree? All right. And it's counting by pi over 6. So you put in second pi divided by 6. It'll do the math for you. Okay. Our y min, what is our lowest y value? -1. What is our highest y value? 1. And we're not going to change this counting. Because this is 0, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. We did pi over 6 because each one is, the intervals are pi over 6. And we're just going to leave the y as y. So when you go to graph, it's going to show you one complete cycle. So this is our cycle. Because, you know, Sylvie draws a little slow. She takes her time. All right, from this, we're going to analyze certain points. At 0, what is the significant at 0? It's a what? It's an x-intercept. Okay? It goes through the origin, goes through the x, therefore it's a x-intercept. At pi over 2, what is its significant? What is it? It's there you go, Emma. It's our maximum. Okay? At pi, we have another x-intercept. And we have a min now. And then at 2 pi, we have x-intercept. I mean, yeah, it's an intercept in general. Yes. All right. Those are your key values every time you're graphing and transforming the sine function. Okay. These are the parent function values that we've used. So when we are transforming, these are our important values. Okay. The other ones, we can't really always graph that perfectly. I mean, I can't graph square root 3 over 2 perfectly, but the main things that you're doing are your 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, -1, 2 pi. Okay. All right. I call this our snake. So for me, the sine graph is the snake function. Do you get why it looks like a snake? Yeah, it's like, little snake. Okay. And that's going to be, we're going to learn about cosine next and play with. All right, let's analyze it. So looking at your graph and looking at your table, if you need to, on what intervals is the function increasing? So you're looking at your graph or your table, on what interval is the graph increasing? Huh? Yes, brackets. 0 to pi over 2, and where else? Good job. So we're from 0 to pi over 2, and we're from 3 pi over 2 to 2 pi. Agreed? Increase, increase. Okay. On what intervals are we decreasing? Pi over 2 to 3 pi over 2. From our max to our min is our interval of decrease. Agreed? All right. So establishing our max, whether it's our max point, pi over 2, 1. What is our minimum point? There we go. Okay. How do you feel so far about analyzing the parent function? Good? Doable? Easy peasy? All right. So let's look at the snake. So now you don't need your graphing calculator for a minute. Here it is. Yay. Sine x. Oh my gosh, it's so beautiful. Look at our snake. Okay. I'm just gonna kind of go over some patterns to help you memorize the key points, because these are the points that you're moving during transformations, okay? So these 5 points are what's moving during a transformation of a sine function. I know, okay? I don't know how you want to remember it. I just remembered it as x max, x min, x. I don't know. That's where my brain went. X max, x min, x. That I don't know. You have to come up with your own rule, your own pattern. You can do intercept max, intercept min, intercept. I don't know. I don't know how else to tell y'all, but those are gonna be your key points. So we're gonna make a table of just our key values, okay? So for our key points, we have 0, 0. We have pi over 2, 1. We have pi 0. We have 3 pi over 2, -1. And we have 2 pi, 0. Okay, and that's what forms our snake. Now, you guys kept asking about transformations. What transforms the sine function? It's still gonna be, it's gonna always be the shape. It can go up and down. It can go up and down. All right, so my domain. What is the domain of this snake? From negative infinity, all real numbers, right? What is the range of my snake? -1 to 1. Okay. Your A value is what's in front. That's called your amplitude. Your amplitude is the absolute value of your A, and it's going to affect your Y's. So it affects the Y. Your key points, you already know the 5 points. Check the table. You have 5 key points. Your A. For right now, it's 1 of the parent function. Yeah. Oh, it's like if yeah, so A equals 1 for our parent function. There's Casper the Friendly One. Exactly. Yes, so we don't say stretch anymore in AP Pre-Cal. It's called a dilation. Sorry. Yeah, we're all dilations now. We're vertical and horizontal dilations. We're going to talk about that. Dilation means that you can get big or small. Dilation is the word we will be. I don't know. No one knows. All right, your period. Your period is from where one cycle, how long it takes for your snake to form, right? Because it's a repeated pattern. It's happening. It's periodic, right? It's happening over and over every period. You're getting that same snake formula function. So our period is 2 pi. Good job. Because how long did it take us to form? From 0 to 2 pi. No, I'm so glad you asked. Your period will change. Your period changes if your B value changes. So it is a horizontal dilation. Good job. Okay. Your B is if your X is being multiplied. So your period affects your Y, your X. And our X's are what? Liars. Yeah. Because how long did it take our snake to form? 1 full snake takes how long? If there was like a really long snake, then you would look at where does it start to where does it end? It's 1 unit circle. You've gone around the circle 1 time, right? If I go around again, that's another period. If I go around again, 3rd period. Every rotation is a period. Does that make sense? All right, that's our parent function. Are we ready to do our first transformation? Already. Oh, well, here we go. We're going to talk about vertical dilation, my friends. So you should have room at the bottom somewhere to write. This is an example of vertical dilation. That's right. Dilation. Like, how do you spell that? Meaning your A does no longer equal 1. So your A is no longer 1 because it says y equals 2 sine of x.
Oh. So A equals
2. So our A no longer equals 1, which is why it's a vertical dilation. Y'all are so smart. I love it. All right. So we're going to just talk about using the plugging in. You always have your plug-in method, right? So if I give you a change in a function, you can always just simply plug in. Does that make sense? So this is an example where we're just going to plug in using the new formula. So y equals sine of 0. I'm sorry, 2. I was coming back. He's the killer.
absolute value of A. How do you get a reflection?
The negative is what causes it to reflect.
If it was like negative,
Your amplitude is your absolute value of A. Your transformation is the whole A. Does that make sense?
it's 0.
Okay. So then we have y equals 2 sine of pi over 2. Then we have y equals 2 sine of pi. And you have y equals 2 sine of 3 pi over 2. And you have y equals 2 sine of 2 pi.
Calculator, like using the degrees values rather than the radian values, like will it give you the same equation?
Yes, but values like this would be on the non-calculator.
Yeah, but
Yeah.
like if you put in the degrees values, it would give you the same graph.
As long as you're in degree mode, yes.
Oh, cool.
Yeah.
Yep. For this, if we didn't.
So if we were in degree mode, we have to change our settings from 0 to, our x's would be from 0 to 360. Does that make sense?
Wait, so for this,
We're not doing that. We're using our brain. What is sine of 0? So this is going to be at 0. Yes? What's the sine of pi over 2? 1. So 2 times 1 is? You have to know it. That's why I said we have to learn our unit circle because you won't be given it. What's sine of pi? So 2 times 0 is? What's the sine of 3 pi over 2? So what's the value? Negative 2. And then what's the sine of 2 pi? So it's going to be at. So this is my. Pretend I went through all my points. So on this graph, we now have an amplitude of 2 because our high and our low are 2 units from our middle, right? I said when all this fails, we're going to go old school and plug in. We're going to do both models. Yep. Okay. Trust the process, Annabelle. I'm not going to leave you out there in the dark. All right. Now, lo and behold, sine, cosine, and tangent, they have some step siblings. They're called cosecant. We have secant, and we have cotangent.
That's not.
Okay. So your cosecant is the reciprocal of your sine. So it's 1 over sine theta. Secant is the reciprocal of cosine. So that's 1 over secant theta. And cotangent is the reciprocal of tan, which is 1 over tan theta.
It's not like the like.
Oh, I meant you didn't see that. This is supposed to be cosine.
It's not like the sine -1 theta. What is it? With like the inverse.
Hold on. I'm listening. I gotta correct something. No, Bob.
Oh, yeah, because it's
It won't let me erase it. Yeah, but it won't let me erase it. I gotta be smart.
He's white.
I don't think they're doing anything. Why would like just write it next to it?
I know, but it's
Cross
not
it out.
bother me.
Done. You got it, girl.
I changed it to white and now I don't see it. There it is. But I've done a video where I thought my pen was broken, but I had just changed the ink to white and I couldn't.
How long did it?
I know it was recorded. It was on a lot. I was like, oh, I'm an idiot. I know. I was like, what is wrong with my pen? It was just working. It's 1 over cosine. Yeah. S.
I switched called like S goes to C.
Yes, they switch.
I like that.
Every S has a C and every C has an S. All right, so this is your teacher being a nerd. So you know how like sine, cosine, tangent has like the super cool thing, SOHCAHTOA, like there was nothing for cosecant, secant, cotangent, right? There was nothing, right? So I am at this time I was an extra nerdy Harry Potter fan,
Oh.
and I've toned down in life, man. And so in my mind, do y'all know like Harry Potter speaks to snakes? Yeah, that's his thing. And so in my brain, I just pretended that this was snake language, and I just started going. My teacher's like, "What are you doing?" And I was like,
What?
and that is. I just feel like this is me being transparent, and that's how I remember. Spit it all together. I just put it all together.
She's like that.
So
Stay slow.
you gotta say it fast, otherwise you're not speaking to snakes.
It takes for it to be
Stop sharing it with you, 16-year-old Shauna thought, I got this.
everyone during a test goes. No, I missed it.
During the AP test. Then you'll all know you're all on the same problem then during the test. Well, I just thought, oh, I was super popular. I was a cool nerd. I was super popular. I really was. I was voted best personality for girl out of 746 people. Yeah. Just saying. Yeah. No. They just loved my personality. And I dated popular guys. I was legit. Don't worry. Don't worry about me. Yeah. They accepted me. I didn't try to be no one else. I just tried to be me. He was special needs, Beth. Huh? We don't have to bring that up, Ren.
The Muslim girl. Wait,
I'm a wizard. It says it's a wizard. It's the whole collective. It's just wizards. Everyone's a wizard. Anyways, so what I would like you to do, haters, you're going to fill in the sine, cosine, and tangent for your 0 to pi and find their reciprocals to fill in for cosecant, secant, and cotangent. We will do 0 together as our model. Huh? Really? Oh, I'm fine. It's never stopped this show. So it's never stopped me. All right, so here we go. Ready? So we know that sine is what? 0. The sine of 0 is 0. The cosine of 0 is 1. There's a reason why we typically write sine before cosine, because it helps you with your tangent. Tangent is 0 over 1, and 0 over 1 is 0.
It's passing out her pen.
Oh, my pen was broken. That's not a real one.
over sine would be 0. So would all of the, I mean, 0, like across the board?
Really, guys?
Across the board, would it be 0 all the way?
Would that be undefined?
Oh, wait, no, I'm stupid.
It's just-
Oh, it's 1 over sine. 1 over 0.
It's 1 over sine.
Oh,
Okay?
I thought we were doing.
Yeah, no, remember, we're doing 0 together and y'all are gonna do the rest. Ready? All right, so now we're on to their reciprocals, right? So we're looking at 1 over sine. What was sine? What is 1 over 0? Undefined. Secant is 1 over cosine. What is 1 over 1? Perfect. Cotangent is 1 over tan. What is 1 over 0? Undefined. Do you see what I want you to do with the rest of the 4?
Yeah.
Can you do it? All right, go. All right, here we go. So pi over 2. What were your sine and cosine for pi over 2? 1 and 0. So what was your tangent? Undefined. And now we're going to do the reciprocals. What was our reciprocals? 1. Undefined then. 0. Perfect. What is your sine and cosine for pi? -1. So tangent is? Our cosecant theta is? Our secant theta? And our cotangent theta. Undefined. I was like, oh, that was weird.
I think I'm an excellent.
How do we get 0 for cotangent? Because tangent is 1 over 0, right? And if I was to reciprocate, where's my 0 now? If I was to reciprocate, it's now in the numerator, and 0 divided by 1 is 0. Cool? 2 pi and 0 are gonna always be the same. All right, 3 pi over 2, where am I at? -1 and 0, so we're at undefined, then we're at, and then 0, and this is gonna mimic okay. Everywhere there's an undefined means that there's a asymptote. Undefined equals vertical asymptote. Well, they're not all in the same graph. Okay. Everywhere there's an undefined, that means we have a what? Vertical asymptote happening. Okay. So for sine, does sine have any vertical asymptotes? Nope, sine doesn't. Does cosine have any vertical asymptotes? Does tangent? Yes, the tangent vertical asymptotes are going to be on the multiples of pi over 2. Okay. At cosecant theta, do we have vertical asymptotes? Yes. At secant theta, do we have vertical asymptotes? Yes. At cotangent? Yes. Okay. Just y equals tan. Y equals. Oh, the reciprocal, you would write this. This is what you would type in the calculator. You write it as 1 over sine theta. Sine -1 is the inverse, not the reciprocal. That's why I said don't call this inverse. This is reciprocal. So when you're no, they're not the same thing. Reciprocal and inverse?
Yeah, but like, isn't 1 over 10 of theta 10?
No, not in trig. I know. I know.
Like, with the math would
What-
be different?
The math would be different for inverse. Inverse trig is not the inverse you're thinking. Inverse trig means that you're looking for your trig ratio. I mean, you're looking for your angle.
It's like you cancel it out to get the.
Yeah, you're canceling out to get the angle. That's why I keep encouraging y'all to say this is the what? Reciprocal, not the inverse. This is our reciprocal. So in the calculator, you would be putting 1 over sine theta, 1 over cosine theta, 1 over tan theta, and you would see those asymptotes. Not on these yet. All right. Okay, let's check our knowledge of rules. Okay, so now we're gonna do an example of where b is not equal to 1. So notice that our b is not equal to 1. And our a is also not equal to 1 in this one. What is our a equal? -3. Do we see that? Okay. Your b affects which one of your variables? Your x, and your 3 is going to affect your y. And that'll happen naturally when you multiply. So notice that this is a table of coordinates and rule, okay? A table of coordinates and rule is different than a table of ordered pairs. Does that make sense? Okay. If I'm given the coordinates, the rule is saying, how am I changing the X and how am I changing the Y? So my rule that I'm following, what is affecting my X? The 2, the B affects your X, and our X's are liars. So it's not multiplication by 2, it's 1 over 2. It's the reciprocal of it. Okay. Our A is affecting our Y. So to each one of our Y's, we're going to multiply by -3. So do you see the difference between an X and Y table and a coordinate and rule table? Yes. Now we're going to apply the rules to each one of our parent function points. Okay. So do I need to write the math out, or we okay just saying it out loud? Okay, cool. So 0 times a half is -3 times 0 is 0. So 0 is still there. Pi over 2 times 1/2 is pi over 4. 1 times -3 is -3. Pi over 4 is halfway between pi over 2 and 0. So from here, I'm going to drop down to -3. Pi times a half is 0 times -3 is. So at pi over 2, I'm at 0. 3 pi over 2 times a half is 3 pi over 4. -1 times -3 is 3. So at 3 pi over 4, which is halfway between half and a whole, I'm going to go up to 3. 2 pi times a half is, and -3 times 0 is 0. So here is my transformed. How do we feel? So this is your other method of graphing using ordered pairs and a rule. How do you feel about the ordered pairs and rule method? Doable? Yeah? Now we're going to describe the graph. So how did this transform from our parent function? So we have a vertical dilation by 3. The negative tells us what? It's we have a reflection, I'm listening, over the x-axis. Over x-axis. What else happened? So that means we have a what? Horizontal dilation by 1/2. By 1/2. Yes? How do we feel about that? The other thing that we need to be comfortable describing is your amp and your period. So your amplitude is how far your highs and lows from your midpoint. So our amp is 3. Your period is how long did it take you to make your pattern? Pi. Yes. Still good? Your B. Your period corresponds with your horizontal dilation. Remember we wrote that here? That your period is going to always be 2 pi divided by B. So you can always check yourself on your period. Yes. Your amplitude is always positive because it's your distance from your center. That's why it said, remember we wrote absolute value? So your amp is going to always be positive. Okay. All right. Now on this one, our A does not equal 1. Our B equals 1. And now we have a new friend. That friend is called D. And D does not equal 0. What is D going to do? It affects our Y. When you add or subtracting. So if it affects the Y, like Lydia said, it's going to make it go up and down. Okay, D has a special line. It's actually called your midline. Okay, so your D value equals your midline. It's now the middle of your period.
So it's like moving the x to two?
It's shit.
Wait,
Yeah, that's what we're doing.
so wait, can you do an example on like number two, like, wait, are we doing this one together?
Yeah.
Oh,
We're about to.
that's like-
All right, so again, I'm doing the coordinate and the rule. So based on what I know, is there anything affecting my x's? No, but there are things affecting my y's. What am I doing? 2y plus 2, perfect. So my x's are going to stay the same. What is 2 times 0? 0 plus 2 is 2. And we have pi over 2. 2 times 1 is 2. 2 plus 2 is 4. You said it with so much confidence, guys. It's okay. Just let go. Just let go. Okay. Negative 1 times 2 is negative 2. Negative 2 plus 2 is 0.
Power on number three still. It's really hard.
Oh.
Still. Don't skip past that.
Oh, when Annabeth had her moment, I just thought if I just worked through it, we would stop talking about it. Okay. So now we're going to plot it. So we're at 0, 2. We're at pi over 2, 4. We're at pi, 2. 3 pi over 2, we're at 0. And at 2 pi, we're at 2. So my snake is now going. So now our midline is, that's why I said D equals your midline. Do we see our midline? Your midline is important because that's double checking like what your amplitude is, okay? So your amplitude is saying how far are you from the middle of your graph, okay? That's why it's the absolute value of your A, right? So our amp is what? 2, because that's how far we are from our midline. All right, what's my transformations that took place? So vertical shift, shift by 2, up 2, not by, because we're not multiplying. Up dose. And then we have a vertical dilation by 2. And anything else? Nope. Did our period change? Why did our period not change? Because we had B still equaled what? 1. So our period is still the same. Okay? Yes, yes, yes. Mm-hmm.